Mabongi.
All right, so I think we can start the session. Can I just get a volunteer who's gonna admit people in as they come in? Can one person raise their hand to just allow people into the session as they come in? All right, Ntabi saying thank you. Thank you. All right, good morning, everyone, and welcome to this very interesting lecture. I've seen the comments that have been posted in the socials and also from the emails. The people were really excited for this topic. And also, even for us, it is a nice topic that we have decided to introduce as part of our training program to incorporate it in some of the tasks that some of our trainees are doing here at NGI. So today's topic is GIS and artificial intelligence. So today we'll basically understand how these two meet each other in industry, in practice, and also in our different day-to-day work streams. So the purpose of this lecture today, so it won't really be a lecture per se, but it will be an engagement. We have a very special guest with us today. So he will just take us through his experiences and knowledge. And the lecture has been organized for training and skills development purposes, and also for sharing information. And I think as we are listening to the lecture today, let me just mute everyone. Can Sabiseng, can you also assist with muting people as well? Yes, in case people do come in unmuted. All right, apologies for that.
I don't think I have access to do that.
Okay, I'll mute the people, don't worry.
Okay.
Thanks. Yes, so as we are listening today, there is a point of reflection that I want us to keep at the back of our minds as we are listening to what Julian will be sharing with us today. So the question is, how can we exploit the capabilities of intelligent technologies in our respective work streams? And because today we are mainly focusing on artificial intelligence, and a lot of us are working either in a data creation space or we are analyzing data. So how can we exploit the capabilities that we're going to hear about today in our own day-to-day work streams? So that's just something that I want us to think about as we are listening today. So before we get into the actual lecture, I'm just gonna share a bit of history in terms of, how we got to where we are today. And it all started when the digital computer was developed in the 1940s, in the early 1940s. And as you can see on your screens, there's an image of the very first digital computer, which was the ABC computer, which was developed in 1942. And initially, when these digital computers were developed, they could carry out very minimal tasks. But over the years, they've been programmed, obviously, to carry out more complex tasks. And their improvements earlier on were largely focused on the processing speed and their memory capacity. And initially, their limitations were around their inability to match full human flexibility. But obviously, as we've seen with the rise of artificial intelligence, computers have basically tried as best as possible to match, our capabilities as humans. And these include, examples such as the voice recognition technologies that we have today, handwriting recognition, search engines, medical diagnosis technologies, and the one that students love to use the most is the ChatGPT technology. And then, so I'm just going to share a few quotes from some industry experts in both the geospatial space and also the artificial intelligence space, and what they have to say basically about these technologies and how they meet each other. So the definition of artificial intelligence, this is for those who may not know or what it actually is. Yes, sorry. It's mutes. Sorry, it's mutes. So the definition of artificial intelligence is that it is the ability of a digital computer or a computer-controlled robot to perform tasks which are commonly associated with intelligent beings. The term is frequently applied to the project of developing systems endowed with the intellectual processes and characteristics which are basically characteristic of humans, such as the ability to reason, discover meaning, generalize, or learn from past experience. So what the computers today can do is basically what we as humans thought was, or initially believed was exclusively for humans. But because of the day-to-day needs in operations and our own day-to-day needs, we've basically created a space where we need computers actually to be able to do the things that we can do as humans as well. And we're going to see some of the benefits of this as we hear the lecture. But I know there's also a lot of debates in industry about the disadvantages of us using or relying too much on artificial intelligence. But the purpose of today's topic is for us to see some of the benefits, especially in our geospatial industry. So today we also have a quote from the CTO of the ArcGIS Enterprise Development at Esri, and this is what he has to say about AI and GIS. So he says the previous generation of GIS technology was built for people, and now we have GIS which is built for machines. Automation doesn't mean that we're replacing humans. It means humans don't need to do the tedious work that causes a state of boredom. Data scientists can focus on what they're good at, which is innovation, and machines can then take the innovations to scale and perfect the readings, focusing on accuracy and outcomes. And then also we have another quote from John Walter, who is the president of Geospatial Content Solutions at Hexagon. And he says, if we think about aerial mapping and the large areas and volumes of data collected, AI is an obvious solution. For example, we currently use AI extensively for LiDAR, point cloud classification, mesh creation, orthophoto mosaic, seamline generation. AI is an enabler that makes generation of certain products possible, in addition to accelerating the workflow and improving overall quality of other products. So the industry, in a nutshell, is excited about AI and how we can exploit that for GIS, and which is why today it was very important for us to have an industry expert in this space, both in geomatics and the space of artificial intelligence. So without wasting any further time, I'm going to just give a brief background on today's speaker, and then then we'll just give it over to him to then take us through today's topic. All right, so today we have Mr. Julian Nkuna. I'm fortunate enough to have met him when we were both studying at UCT. I'll say back in the day, because it was obviously about a decade ago or so when we were studying together. And, I'm very excited about the things that he's been able to do and accomplish since then. So he has a Bachelor of Science in Geomatics from UCT, Master of Science in Computer Science, and he specializes in machine learning, also from UCT. He's highly experienced. So he was here at NGI as an intern from 2012 to 2015, and he's done research at Pick n Pay, and has also worked as a data scientist at various companies. And he also worked, for various companies, which include Pick n Pay, Takealot, and the ShopRite group of companies. From 2020, he started founding his own companies, or he ventured into entrepreneurship, and he founded two companies, which is the Bantu Byte and the Timbuktu company. But I think he's going to tell us more about what he's done. And then, so without wasting any more time, I'll just hand over to you, Julian. And thank you so much for agreeing to come and speak to us today. Thank you. So I'll just hand over to you. I'll stop sharing now. All right, Julian, yeah.
Fantastic. Thank you very much for the invite and the opportunity. It's wild to hear that it's actually been a decade since we studied. time flies when you're having fun, I guess. I'm just going to share my screen and then we're just going to jump straight into it. Let me know if you can see my screen, and yeah, I'll try walk through the presentation in a, just give me a view if you can see the screen.
Yes, we can see your screen.
Okay, cool. So the topic for today is, so maybe just by way of introduction, I think Nozipo has done a very good job of giving sort of context. So I'm going to speak about the implications of generative AI on geospatial analysis. And I'm just going to sort of give a brief intro. So as the intro spoke to, I've basically, my background is in geomatics. I spent the decade since I left school in around 2015, 2016. And I've basically been working as a geospatial data scientist, but also a data scientist in sort of a more specific descriptor. And I've worked mainly within that context. So I want to say that I'm not necessarily an expert in GIS. A lot of what I'm going to be speaking to is geospatial data science, which is a merger of data science and geospatial sort of analysis and tools. So I'm also the founder of Timbuktu more recently. It's a location intelligence startup where we basically use what we would traditionally call GIS and the merger with generative AI to generate insights for businesses. So I'm just going to sort of walk you through this sort of journey of mine. So one of the core questions, I guess, that's being asked is, what does AI mean for the knowledge worker in the modern world? And by knowledge worker, I'm speaking to all domains. So anyone who has to do with some function that includes some digital device, a machine, there's processing of some data, and there's some insight. So GIS is majorly focused on that type of function, regardless of how you do it. So I've given this talk to data scientists before as well, and one of sort of the ideas around one of the sort of big sort of concepts that are coming around is, will data science soon be obsolete due to things like GPT? And then in sort of the GIS space, there's papers that have come around in the last couple of years asking the question, is ChatGPT a game changer for GIS? What does it mean for all of us? One of sort of the bigger responses in the market has been that AI is not necessarily here to replace whatever domain you're in. So I use data scientists in this context, and you can replace that with geospatial data scientists. But humans who use AI will replace the humans, unfortunately, who don't leverage this technology. So this is just a view to contextualize the trends. So this is effectively all the search trends online. This is from Google to speak to what the interest in GIS has been over time versus data science. And it's basically not necessarily to raise alarms. It's to speak to the fact that, as you can see later on, within recent years, there's been a convergence where data science, which is effectively less than a decade old, has now sort of like converged, and there is some sort of like convergence, which is what we're going to focus on. So one of the sort of larger concepts within the data science domain is, and in knowledge workers in general, is as sort of the intro spoke to, we basically have moved and abstracted ourselves away from talking to hardware. So if you want to take it back to the day, back in sort of the 70s and the 60s, we're using sort of talking to machine code more directly. There's punch cards and, the ways that people were sort of talking to machines back then. And over time, if you look at sort of the trends of what we're doing, we've moved from, direct hardware to machine code to assembly to high-level language. And this is basically people, 30, 40 years ago, talking in zeros and ones to machines, to us in the modern world using all these fancy languages. Python is a very popular one within the data domain. And obviously, we've got support like Stack Overflow, which is where most developers get most of their code. And then in sort of the modern world, we've got things such as GPT, where you can now speak human language instead of writing fancy Python code. You can effectively speak human language, and code is generated, or some function or analysis is performed. And I've tried to sort of link this with something like an ArcGIS, which is a software-based tool, but I'm going to speak to that now. So speaking to that notion of software and the distinctions with how we think of geospatial data science, and something such as, GIS is effectively, years ago when we were sort of coming up in sort of the GIS domain, we mainly used desktop software such as the ArcGISs and the QGISs and those types of tools. In my career in particular, I haven't touched any of those tools in probably, almost a decade. And it's not saying that they're not necessarily relevant. It's to say that we found ways within things like Python and Jupyter notebooks, which is what you're seeing on the screen here, to basically do geospatial computations and analysis, which we would have done in these tools. Data scientists are just using this technology now in terms of Python to do some of these functions here, where you can generate your maps, but you can also do sort of multi-disciplinary actions there. And the reason we do this is because more and more we're becoming agnostic towards software, but also there's a growing ecosystem for this. So for instance, some of my team at Timbuktu, no one is trained historically in geospatial, but most of the work we do is in that domain. And the reason we're able to do this is because of the level of support here. So for something like Python in data science, geospatial data science, you have all these effective libraries which you can leverage in one sort of ecosystem to solve a particular problem. So if you are visualizing, you can use, and this is just some of them that I could fit on the screen. There's like hundreds and thousands. So in one notebook, a notebook being something that looks like this, we're able to access whether you want QGIS, ArcGIS, any sort of library from these different platforms, and we're able to basically build solutions. And there's so much variety that's basically how we work. Now, I want to speak about sort of the idea around generative AI. So I'm not a lecturer, so I'm going to focus mainly on sort of practical implications. So what's happened is, as researchers in artificial intelligence, one of the tasks that we've been trying to do for some time is effectively, there's been a domain called NLP, or natural language processing, and under that you've got certain domains. So the way you can think about this is there's scientists in machine learning who are dedicated to teaching the machine how to understand and speak human language. Now, generative AI is effectively, we've now gotten the machine to understand human language. And one of the breakthroughs, as you've seen in the media with things like ChatGPT, is the machine can effectively now respond at a level which seems very, very advanced. And that's what generative AI is. Generative AI is built on these notions of language models, which you can think about as statistical or probability distributions of word sequences. So effectively, what the language models are doing is they've taken all the data on the internet. So everything that we've ever put as human beings on the internet, we've trained this model, and the model has just learned patterns. So it now understands if you say certain words, the most probabilistic words that it should respond by are certain words. So maybe here's a view of like what early models look like. So back in the day, we used a lot of sort of neural network type models to solve this problem. And there were some issues around that because it could effectively, LSTMs and GRUs back in the day could only speak in one direction. So it couldn't understand context in the sense that if you say something like, how do I install a subwoofer in my trunk? It effectively understands this in a unidirection. Later models such as bidirectional LSTMs started to sort of look at, if I'm interested in a word, so remember that it's just guessing one word at a time within the context, It's now looking at, well, what are the words that come before it? What are the words that come after? So the fight that the researchers have been trying to get to is teaching this thing how to understand context, because there's so many contexts in which you can say the sentence and you can change the sentence and it changes the context. One of the biggest breakthroughs was the BERT model in a paper called Attention is All You Need in 2017. And this is effectively when language models started to understand context, which is that now if you ask it a question, it would understand you at the level in which a human being would understand context. So in 2019, the paper came out and basically BERT was superior in performing classification tasks, which becomes important for our conversation today. And also the idea that you could now take this model and train it to do other things. So they've trained this model on all the internet. You could now take that model and you could effectively fine-tune it. Fine-tuning is effectively just training it to perform other tasks which are related to what you're doing. And this is effectively just the mapping of how we thought about how we got to sort of language models. And if any of you guys have been introduced to the idea of machine learning through classification, I'm not going to go into depth. The idea is that you can have unsupervised and supervised learning, and there's a bunch of models, which is what we came up in machine learning using. So things such as the probabilistic models, the linear classifiers, the neural networks are still very, very popular. But one of the breakthroughs was within these neural networks, transformers, which was the major breakthrough. It's a technology that ChatGPT and all these other models today are using. Came through, and these effectively become what we call foundational models, which I'm going to speak a bit more into. Now, this is just the mapping of how this has actually played out over time. As I said, historically, there was a view of LLMs, not being as powerful. They were computationally expensive. It was very, very, I mean, imagine sort of like trying to train the entire internet on a neural network that's basically taking one word at a time. We didn't sort of have the computational sophistication to do that. And then there were some breakthroughs, as you guys would know by now. GPT-3 was released recently, and things like GPT-4 were released more recently. Open source LLMs are now such as the ones by Facebook, and other sort of open source environments have been released into the world. Now, what does this mean for all of us within the geospatial space, at least within the context in which we work? So the idea with generative AI is that it further abstracts away the ways of working for geospatial analysis. And the big question we're trying to sort of speak to is, how does a modern geospatial data scientist, you can replace geospatial data scientists with GIS practitioner. Actually, you can replace it with any form of data processing, which is sort of what all these, you can replace geo with any other sort of data set, and it still speaks to sort of a similar sort of environment. But I'll focus on geospatial analysis. So the idea is generative AI is over time becoming the primary interface for analysis. And this is because natural language processing is effectively, natural language processing is basically being leveraged. So natural language, being the language that we speak as human beings, is being leveraged as the user interface to interact with geospatial tools. What do I mean by that? What I mean is that historically, so going back to the example of the data scientist who's writing code, the code now can basically be prompted. So in this example, someone is basically telling GPT, can you create code that does this and this for me using this particular library? Going back to those libraries I spoke about, the code is generated, they paste it in GPT, and they have a map, right? And you can do so much more with that. But the big idea here is you now have basically that ability to do something like that. But not only can you do that, you can now take something like this, you can write code which you don't actually have an understanding of. So for instance, this is an example from our platform on Timbuktu AI, which was generated using this type of workflow, but generated in HTML and JavaScript. Now, and the data scientists that produced this, which was shared on an interactive map, literally had no experience in JavaScript, but they were able to prompt GPT to do something like that. So the big idea is that human language is becoming a primary interface, and this is a more familiar tool within the GIS domain. So this is QGIS, which is open source. And more recently, QGIS has started exploring with leveraging generative AI interface. So effectively, you can now ask questions, and it will give you responses on something like this. It's not a mature product, but you can start to see, you should take a snapshot in time of where we are right now. So historically, we are interacting with sort of the geospatial components of a map and all sort of the features on the side, and now we're starting to interact with these things like that. Now, here's sort of another example which maps into QGIS, which is basically someone gives a prompt to say, can you write a script in Python specifically for QGIS? This is what I want to do. So this person wanted to extract and export Senegal as a shapefile, right? It gives the person exactly what they have to do. So not only does it produce code, and it also sort of tells them exactly what they need to do. They follow the instructions, they copy the code and paste it in QGIS, and it basically does the functionality. So this is for sort of existing tools, and this is the infant introduction of where these tools are basically starting to go. One of the sort of other advances in this field is that the language models are now starting to be used to build spatial models. So the exact same logic that I explained about how language models are trained. So if you take all sort of conversation and text that exists on the internet, it's starting to be used to build on spatial models. More recently, the Meta AI, which is the parent company of Facebook, last year they released a model called SAM. Some of you guys may have heard of it. And effectively, it's using within computer vision a similar architecture to perform some of these functions. So in this case, the example here is showing it performing a SWOT analysis for some classification, and it's basically performing segmentation. And the idea with these is that they're not sort of domain tied, which is why I'm wary to say this is a geospatial model. It's a spatial model in the sense that any physical sort of, this is being used in things like Photoshop by graphic designers and by people who have to deal with anything visual effectively. Now, within the geospatial domain, obviously, we deal with the visuals, which are to do with the geo component. So this is an implementation as well where these computer vision, generative AI powered views such as effectively called LSMs, so large spatial models, they integrate into the existing ecosystem. So this is a Python file. We've taken that model, that LSM model, and you've basically leveraged that, and in a few lines of code, you're now able to perform a hypersegmentation, which generally would have taken a lot of steps historically. And this is something that you can now do with a few lines of code that are generated for you by the generative AI. And the big idea is that generative AI is abstracting away sort of things like complex queries. So within this domain, generally querying sort of large geospatial data sets is something that's very sort of a complex task in the sense that those queries can become very complex, but organizations that deal with within this domain, such as Kato, they've started to integrate and what you'll notice here is you ask yourself like, wait, how do I interact further with this tool? And you'll realize that, well, your SQL editor, which now speaks English, so now you're basically writing a query which you're telling, give me the healthcare facilities in the south of Spain, as opposed to writing select, this in this country and while this and this, and it's going to go do all of that for you, and it basically appears on the interface as you sort of write that in human language. And there's sort of like emerging fields like this idea of geo-LLMs, so geospatial large language models. So companies such as Geoforge, they've taken these workflows and they're basically starting to, and it's a similar workflow effectively where You ask a question like, show me a map of regions in Bangladesh, colored according to this and this, and you can make it more complex. And it basically understands a specific language with the GeoLLM. It goes and creates a solution graph, and then it writes the code for you that can basically execute separately. It sends a request to the textual solution graph, it interprets it, it runs the final function, it gives you a map, and this is what that looks like. So what that looks like in practice is the user asks the question, please show me the administrative boundaries of Bangladesh and this and that, and here's what appears over here. And you can just imagine the level of power. And all that these guys have done is they've taken the existing OpenAI GPT-4 language model, and they've just trained it with geospatial vocabulary. So they've taken that model, they've fine-tuned it. Fine-tuning is effectively just training on top of an existing foundational model for these tasks. So they just made it specialized for geospatial. And now all of a sudden, you can imagine the power of this type of analysis. Another massive breakthrough, which takes us towards the idea of what some are calling map GPT, is the idea or rather the advancements that have been made by NASA and IBM, where they've taken the OpenAI GPT model and they're using it for real-time Earth observations. By that, what I mean is they've basically taken high-resolution imagery and they've taken sort of the spectral context from those and they've fine-tuned models. And what that looks like in practice is something like this. Let me know if you can see my screen. I'm playing a video right now. So this over here is how analysis. So what's happening here is this is exactly like a GPT in the sense that they're basically feeding these high resolution imagery data into these large language models in real time. And you can now basically take this model and analyze anywhere in the world to answer some, let's say, specific questions. So you just keep playing it. So here's like a bunch of like specific questions that, they might want to ask. So they've just made it easy by saying, okay, where's potential fire impact? So now in real time, wherever this is in Texas in the United States, and you can sort of choose whatever inference task you want. So they want a view of these fire scars between a specific date. You can now, without having to sort of go through the traditional workflows, you can now basically have this in real time. And this is sort of updated as a language model. And all that it's doing, it's using the exact same architecture to basically speak to this. So the same thing that you can do with a GPT where you're asking questions, you're now asking questions to the physical world. And this is a major breakthrough because for things like climate risk and like flooding risk and any natural disaster risk, you basically can leverage these types of tools for that type of analysis. And by the way, these models are free. If you go onto Hugging Face, if you use Python, you can literally download that model and use that library, and you can do your analysis or play around with it yourself. So it's a massive breakthrough. And I'm not going to speak too much about the architecture, but effectively the architecture is the exact same that they're using within these types of models that is being used for language models in the transformer architecture, which is basically instead of taking like words or text, they're taking an image, they encode that image, which means that they convert it into these, let's call them numbers, which are embeddings, which we map into feature space. And at the end of it, you basically can ask questions or train or fine tune it to basically do specific tasks. And that's how they work with these types of models. Some of the more interesting works is this idea that's coming up around towards autonomous GIS or auto GIS. I encourage anyone to read this paper. It's it changes the game quite a bit. So this paper was from, I think, one of the universities in California. And the idea with this is that taking large language models such as GPT and implementing them within the GIS domain, what are some of those implications? Now, I've already sort of shown the different examples, but the workflow is effectively something like this. You've got some spatial problem, so you've got some question. So you want to ask, could you map the population living with hazardous waste using these data sets, right? Now, the LLM basically takes the input data, it performs the operations itself, it provides whatever intermediate data. Remember that it's got context to data that is not necessarily in your world. So for instance, when we're doing analysis within Timbuktu, we might say, well, based on this exact scenario, so let's say we're doing site location analysis in Cape Town, South Africa, we might leverage this type of technology to say, where in the world is a like-for-like market which leverages this type of, or is asking the type of question we're asking, but also in a similar environment. Okay, based on that, give us a view of the data and the steps that yielded the best results. So this is basically that sort of level of workflow. And then it gives you basically a final answer. And you can see here it's basically generating a solution in this step. The LLM generates what they call a solution graph, which basically is a mapping of what it's actually doing. So it's like, I did this, and then I did this, and I think I have something. Yeah, so this is basically what that looks like. It's to say that, well, I did this, and then I loaded a shapefile URL, I loaded some other shapefile, I did this, and then I did this. And then from this side, I did this, and it's like, this is how I got to that. And you can see, I calculated this. I did this with the population mapping. I generated a map over here. I loaded the shapefile for hazardous waste, and then there was a population map produced. And then you can basically see it here. And this is basically the workflow. So just going back to this, it tells you how the solution was generated. This is how we generate code for each of those operations, for each of those nodes that we spoke to. This is how it's assembled. So the code is generated now, but there's code that actually handles or assembles the code that's being generated to execute as a program. And then it provides you with whatever output you want. So do you want a map? Do you want a chart? Do you want a report? What do you want? And basically you can continue this cycle where, okay, now I want to ask this question. Now I want to ask this. Now I want to do this. And this is basically the workflow that at Timbuktu we've been leveraging as well to get to results a bit faster. And this is what it looks like. So it's like, this is the sort of graph, the solution graph. This is the output that was produced, but it also gives you a view of like, this was the code that was used to do these types of things. So yeah, that effectively brings me to the end of the talk. And I think the gist of this is AI is here to effectively give us superpowers. It's not here to replace humans, but we should be mindful that if you're not leveraging the technology, there are sort of people within the same sort of domain that are leveraging the technologies. And it's allowed us, Timbuktu as a startup wouldn't exist without this type of technology or the advancements that are made in AI. And the idea is to look at this like this meme over here, which shows you've got superpowers, you now know Kung Fu. Thank you very much. That's it. Are there any questions?
Yeah, thank you so much, Julian. So now I think I will take questions. So I think just to have a bit of order, can whoever has a question or a comment, just raise your hand, and then I'm just going to go down the list. And then when I call your name, then you can unmute and give us your question. So I'll just monitor the hands, but I can see some hands clapping here. So thank you so much. Very insightful topic, very insightful presentation as well. So just raise your hands, and then I'll just go down the list and take your questions. Okay, we've got a question from Mr. Motimone. Afani, you can unmute.
Thank you, Nozi, and thank you to the presenter as well. This was quite insightful, and we are grateful for this opportunity from NGI. Just wondering, I see all this, but is there any direct application of AI in cadastral data so far that has been picked up? I see this is mostly raster data. Thank you.
Sorry, maybe just repeat the question. You're asking if there's been applications in cadastral using
Data.
AI.
Yes, thank you.
Not that I know of. So that's not an area that I spend a lot of time in. But what I can say is part of sort of our the data sets that we are interested in bringing in is sort of cadastral data. From what we've seen, particularly in South Africa, with sort of the way the cadastre is set up, it's data that can be analyzed at that level as well. But I don't have any sort of visual examples for that. But it wouldn't, so the data type is really not an issue. Yeah, and that sort of maybe speaks to a broader sort of idea around data, which is that the data types and things like that matter less and less in our world. So I can't remember the last time I said things like shapefiles. Like data is data, and it can be converted to whatever format, and you use it to, or you basically leverage AI to speak to what is the best format to analyze this data. How do I convert it, generate code that converts it, it's converted, and now it's in some format. So that's a job for the machine to think about the data types. We don't think about that anymore. We think of the insights that come from this, if that makes sense.
Yes, thank you, Julian, for that. I think Mr. Mutumane, I think finally raised his thumb, so I think he's happy with the response. So the next hand is from T.A. Lefenyo. I think it's Sepiso. You can unmute.
Unmute for me, please. No. Good morning, colleagues. Julian, what a breath of fresh energy and what a scrumptious presentation that we have just delivered. And thank you so much for the invitation, Ms. Madlala, Mr. Parker. Thank you for the empowering session and resensitizing the need to transform and keep up with the times. Mine is just a comment. I've recently ventured into mapping using Google Earth Engine, as well as using different classifiers like SVM and support vector machine and random forest to do some land use lane change analysis. So thank you so much for just being that one plug. I'm actually going to contact you after this. Thank you so much.
It's a pleasure. Thank you for the comment.
Thank you. And then Chad, I see you had your hand up as well. Do you still have a question?
Hi. Yes. I don't know if you guys can hear me. How's it going, Julian?
Hey, Chad.
So I just saw that you had a map there, and there was some questions that could be answered sort of magically via your LLM. I have a question about whether or not you can feed data to it and it surfaces insights without you having sort of questions before. So the job of a data scientist, right, is to figure out the right questions. I don't want to steal your job here. It's just a curiosity.
Wait, so you're asking if you can feed it the data and it produces insights automatically?
Correct.
Interesting. So normally within these types of workflows, in my experience, is the core job of the modern, let's call it data scientist, is effectively tuning the best questions to ask and how to ask them best to the language model. And what that looks like is not necessarily that it should be giving you insight automatically, but rather if it is, it's directed by the tuning of the prompts. So the prompt tuning is basically a lot of the work that at least in Timbuktu, we focus on. So it may seem as though in other instances it's giving you sort of automatic insights, but you would have given it a lot of fine-tuned prompts as context. So an example is basically something like, here's a data set, but here's your role as an LLM. Here's the context in which you're working. This is what you are solving for, or you are constantly optimizing for this. So that becomes almost like a contextual layer. And then outside of that context layer, now you can ask questions, but every question you ask it, it's through that lens of those of that context, if that makes sense.
Yes, yeah, that's cool. And then maybe a sort of an add-on question to that. I don't know if it's something you've explored, but potentially training one LLM to speak to the other LLM. So training one LLM to be that sort of quote-unquote analyst, to sort of retain context if you've asked questions before that might be useful in future data sets. And then that's my last question. Thank you.
100%. Thanks for that, Chad. And it's something that it's not fully automated, but we do quite a lot. Having LLMs sort of like argue with one another is, yeah, it's quite an interesting thing to do. So normally, the way we've used it is basically getting one model to critique the results of another model, or getting one model to generate the best sort of fine-tuned prompt for the other model, getting that result. That result is basically critiqued by the other model. You take that result is critiqued by the other model as well. And I think there's a word for it. There are sort of companies that are doing this at scale where it's sort of fully automated, but thanks for that. 100% looking into that.
Thanks, Julian. Thanks for the questions as well. I also have my own questions. Okay, Mike has a question before I go into mine. Mike, welcome. You can unmute.
Yeah, thank you very much for the presentations and for putting this together. We have a problem. We need to identify holes in our spatial data. And we haven't really found a tool that will give us a list and location of holes in the data, places where there are voids. So how would we go about doing that? Which of these platforms would be available to us, and how would we begin to do that? If you don't mind assisting with a practical example.
When you say holes, are you speaking to missing data in your data set?
So in the spatial data, there may be places where you didn't capture something, but you don't know it's there. You can't see it. The scale is too large to see the holes. So yes, it's missing data in the spatial data. So as you know, there may be overlaps, and slivers. So you're not worried about those. So you want something that's like wider than 2 meters, for instance, something like that.
So actually, that's something that I probably should have spoken to, which is one of the greatest benefits of LLMs for us in particular has been the idea of generating bespoke but contextualized synthetic data sets. So that's a really, really massive one in the sense that you can now give GPT effectively whatever your data looks like, as an example. And you can give it an idea of the parameters. So within the context of, and traditionally in data science, there's a lot of sort of techniques on how you can handle missing data based on the type of data and all of that. But what you can do now is you can effectively give it the problem as you stated it to me, and give it the data in its raw form. It doesn't have to be in some geospatial sort of formatting. And based on whatever conditions, so the conditions like, things generally have to be a certain size, a certain dimension, whatever context there is. And you can even ask it if your conditions are the most optimal for this problem, and the missing data will not, or the synthetic data generated will not skew the data. And from that, it will generate code for you. So you can do this in Jupyter Notebook, where it will basically generate code which is going to be an algorithm which, given some hole or some missing data in your data set, it will basically be able to generate a synthetic sort of data to fill that data gap, if that makes sense. And then you can sort of export it into whatever environment you're using. Does that answer the question?
Yeah, I think it does. But being a Luddite, I might need to come back to you later for a little bit of direction, if you don't mind.
No worries, no worries.
Thank you.
Thanks, Mike, for the question, and thank you for the response. Let me see if there's any hands. Okay, we've got a hand again from, I'll start with Kumeleni. Kumeleni, you can unmute, and then we'll go to Mr. Mutimone and then Tabi Singh.
Hi, thanks, V. Good morning, Nkuna. How's it, man?
Hey, Kume, you well?
Good, man. I've got a question for you, man. How effective are the LLM when it comes to feature extractions? Like, for instance, extracting building from your raster imagery, or maybe trees, canopy from your raster imagery. Have you maybe done some sort of work in that space? And if so, how effective were those models in terms of extracting those features?
So the LSMs, I would say, in terms of things like feature extraction and identification of specific context, spatial context, I would say that LSMs are the best at something like that, particularly within something like Python. The truth is, when we normally speak of feature extraction, it's not necessarily specifically focused on geospatial. So because the work, we don't do much of a high resolution imagery. We'll do work on, oh, sorry, Kume?
No, it's fine. You can carry on, man.
Yeah, so yeah, I'd say the LSMs are probably the best sort of approach. But I have to admit, on things like high resolution imagery, we haven't done too much work on that. But from what I've been following, things like the SAM models are really doing great work there. And some of these models are they're not marketed as geospatial models, but rather as sort of visual models. So the models that are being used with Photoshop, I think, as a new model now, and yeah, within computer vision effectively, if that answers the question.
Yeah, perfect. Thanks, man.
Cool.
Thanks, Kume. Fanny, you can unmute.
I know. Thanks. We have a data cleansing project. I don't know if we can get an opportunity to present the project to your team and probably look at what tools that we can use in this to try and probably clean some of our data. And I know that would reduce probably the human work that currently we are deploying in the project, but at least if we can automate some data cleansing using some of these features, it would be appreciated. Thank you.
Yeah. Thanks, Fanny. Yeah, we can definitely chat after the session about that. Yeah, it's something that I think would be keen to also assist with. And then Tabi Singh, you can unmute, and Tabi Singh.
Okay, hi everyone. Thank you, Julian, for that presentation. I think for me it was more insightful because as a GIS analyst working for still a paper-based environment, it was very, I think, quite scary to think that in the next 5 years, our positions aren't really as, effective being in a paper-based setting. So I think my question is more towards, does it make sense to transition into into this sort of geospatial analysis from the traditional way with the whole programming, learning Python, learning those natural languages, or utilizing, these generative AIs to transition? I don't know if that sort of makes sense because, do we approach it the traditional way of going through data science from the inception, or does it make sense to slowly transition in while incorporating these in our day-to-day tasks, like the data cleaning, acquiring data, etc.?
Thank you for that, Tabi saying. I think that's a really good question, and I didn't mean to scare anyone. I think sort of the crux of the talk today and the question you're asking has to do with how does this change my particular sort of, or how does this affect my future within the context of my role? And you basically have answered the question in the second part of what you were saying, which is to say that anyone who has started leveraging these sort of AI tools, so large language models within their way of working, is already ahead of the people that are not. So one thing I was trying to say was I wasn't trying to say, you know, we shouldn't be using sort of the existing tools anymore. We should walk away from ArcGIS and QGIS and all of that. What I was saying is that if you go look into the advances in the LLMs, you'll see that within the tools themselves, so there's the example I gave on QGIS, within the tools themselves, they're now starting to build interfaces to interact with this, right? There's a domain understanding that you have as a GIS practitioner, which allows you to interact with that better than sort of anyone. So I don't think it's the idea that anyone in the world can just come into GIS and now just, you know, do this. But the idea is if you have good domain understanding of your domain, so you know all the theory and sort of applications that you have within the field of GIS, and you are leveraging the tools as well, then it becomes a powerful combination. What I'm not saying is I don't think I was trying to say we should all transition to data scientists. The data scientist is less than like a decade old, right? And projections suggest that, you know, it's going to evolve. So if you look at trends, for instance, you'll see that the data scientist is what a data scientist was 5 years ago is a very different thing to what the expectation is today. And the AI sort of LLM advancements have changed that game as well, right? 2 years ago, I spent most of my time writing Python code. This year, 95% of my time is in front of some form of LLM, right? So it's just, I'm still doing similar things. I'm just leveraging the new tools to do those things, if that makes sense. I hope that makes some sense.
Yes, that's a perfect explanation, actually. Thank you so much.
Thanks, Nsabi Singh. And then we have a hand from Tremaine. You can unmute.
Thank you so much, Nazipo. Thank you, Julian, for the presentation. That was a wonderful presentation. Most of the questions that have been asked, I think I wanted to ask them, but you answered them perfectly. The one that I would like to ask is that is it possible to run multiple analysis at once using LLM? I'll give you an example. For example, I mostly do a lot of suitability analysis in ArcGIS, and I usually use a model builder to run multiple analysis, such as clipping, extraction, such as edging, and a lot of them. So is it possible to run multiple analysis at LLM without having to write a long script?
So I would say yes, in the sense that the way that we work using sort of Python and Jupyter notebooks is effectively, let me see if I've got examples here. Effectively, you can run 1,000 different notebooks at the same time, right? So you can basically create a workflow similar to sort of the workflows. I'm not too familiar with what ArcGIS looks like now. But what you're describing is you running some workflow and it's generating a ton of code. The amount of code or the script doesn't really matter. It can generate 1,000 lines of code. It shouldn't really matter too much to you as long as you achieve your objectives. So you can generate multiple sets of codes or in different notebooks, or you can basically frame the question to say, I would like to run these analysis in sort of a parallel fashion. And there is sort of in Python ways to do parallel computing and things like that. So the answer is yes, but I don't know how that would work in sort of an ArcGIS environment. As I said, I think the emphasis has been that we are not married to tools. We're not even married to Python. So Python is cool for now, but it's been cool for maybe just 10 years or something. There's some kid in first year right now who's probably going to come in and just use a very different way of like solving these problems by the time they graduate. And I think that's sort of the emphasis we're speaking to, is not getting married to to tools and things like that, leveraging just whatever is the best at the time.
Okay.
Thank you for that. I don't see any other hands. Is there anyone else who wishes to ask a question? All right, so in the absence of other hands, I did have a few questions, but I think most of them were asked. I just have now one remaining question in that, what can't AI do, especially in our space? Like are there any new areas of research or things that are currently still being tested and explored that we can then maybe, especially for those who maybe want to do further research on it, are there any research topics that have come out of what you guys have currently been doing, or like in that industry, especially in the data science space and AI space? So what is the current research that is still ongoing in terms of, exploring other capabilities of the space? So that is the main question, especially for the students who are still doing their research as well.
So maybe to answer the second part of the question, which is what is the research that's emerging within the space? I'm not full-time in, so in my intro, I think you said that I did sort of my master's specialized in, I did do it specialized in LLMs, but then I dropped out to go do a startup, right? And like the way that academia works versus the way that we work in sort of the startups is there's a difference in sort of the way that we focus on implementation. So we don't really look too much into research that doesn't have an application. What's happening now is within AI in particular, a lot of papers that are produced generally do have reusable code and reusable workflows. So for instance, a lot of the stuff that I spoke to, like this came out of a paper, but this is a company now, right? These guys do have a paper published speaking to how they did something like this. But not only that, you can basically get the model itself. So you can go to Hugging Face's website and you can get this model with the paper itself. And then this as well, this entire sort of paper here, this is basically this being applied. So we focus mainly on application and research that has sort of application. We don't necessarily, if that sort of answers that. The idea with new emerging research areas, I think, has to do with creative combinations of these worlds. So, whatever problems you have, are you able to leverage like these new technologies to basically speak to those problems within the context you're solving them, if that makes sense? I think that,
yes, it makes sense.
Yeah, the combination of those, I think, is something that's emerging a lot. A lot of research that's maybe not bringing out new models or something. It's just speaking to how can I combine this traditional form of, let's say, geospatial analysis and this new sort of LLM to solve this particular sort of problem. So I think someone asked about missing data in geospatial. That's a topic right there. Like, how can you leverage sort of synthetic data generation by LLMs to solve that problem in real time, right? Like, so yeah, I think it's a combination. In terms of what can't AI do, I think there's a lot that it can't do. So the big sort of thing that's coming out with knowledge workers in general is the domain understanding of a knowledge worker. So the ability to ask good questions and extract the best insights using these tools is still sort of the most important thing in terms of like just human domain understanding and being able to sort of guide these tools. It just so happens that you maybe don't need 10 people asking the same question to data now. You might need one or two people that are, very good at asking these questions, using sort of these technologies to ask that. But those people need to be very good. Their acumen within their industry needs to be very good for them to be asking the right type of questions.
Thank you. Thank you. And then we have a question in the chat. It says, can or would AI be able to replace the emotional part of any profession? Who's this? Emil or Emile? Would you like to unmute and just maybe elaborate further on your question?
I think I actually do get the sentiment of the question. It speaks sort of what I was speaking to before, which is that like there's sort of emotional intelligence and softer parts of the human being, I think, are being emphasized a bit more as we delegate more and more sort of like computational tasks to AI. So I don't think it can replace sort of emotional sort of parts of so a salesman, always has to like have like in sort of tech, there's a view that engineering problems, as difficult as they are, there is a pathway towards a solution because science and engineering works a certain way, whereas something like sales is something that's an extremely hard science because it's not something that's figured out. It has to do with human beings and human interaction. So that's why salespeople are paid as much as they do, because they're solving for something that's ever evolving and very, very human heavy, if that sort of answers the question.
Thank you. Thank you, Julian, for the response. Is there any other questions? Mike, I see Mike has a hand up. Mike, you can ask.
Yeah, thank you. So I'm just thinking as we're listening, and if I understand correctly, this applies to fields other than spatial fields. So for instance, if you have an alpha database, a huge alpha database, and you want to generate an index of it, if you had a person who knew how to find the fields where this is, you could go about generating it, if I understand what's been said correctly.
Yeah, 100%. So the talk today was just focused on spatial. The truth is, in my career in particular, spatial has been a fraction of what we do. So generally, and this maybe speaks to the idea of a knowledge worker at scale, is we are domain and industry and sort of functionally agnostic. What that means is we can code switch from data having to do with geo. So for this talk, we are focused on geo, but with the same lens, we might move into things like how does this apply to social media data? How does this apply to other sort of visual data or non-visual data? How does this apply to music or voice data or things like that? So yeah, anything that I spoke to within this context effectively can be leveraged. So if there's a model within the geospatial world for certain things like these, there's advances that are being made within other domains, and the LLMs basically tie everything together. So you can, generate synthetic data for this use case or the use case that you mentioned before, but also you can ask it the questions that you're asking around specific domains where you don't really have a good foundation. We use it as a way to educate ourselves as well, if that makes sense.
All right, see, Mike is happy. I see he's got a thumbs up there. Any other questions or closing comments? Okay, Chad, I see your hand is up. Chad, you can unmute.
Thank you, Z. Julian, one more question, just sort of, it's probably important to most of the people here, but in your experience, what has been like the biggest challenges in sort of getting this type of technology in the hands of the people who need it? So both accessibility and wider adoption. It's really awesome to see demos like this, but unless people are actually using it to solve real problems at work, it's not that great, other than just to go, oh, wow.
Yeah, thanks for that, Cha. I think that's a really important question. And it speaks to one of my biggest frustrations. So accessibility, I don't think is necessarily a problem because all of this is effectively free. Like, I'm trying to remember anything I spoke to today that costs money. So ChatGPT is effectively free. You can, and there's a bunch of sort of language models that are free. And some of the most, so Google Gemini, for instance, they've released the most advanced model. You get it for free for the first 3 months, and you can use their standard model for, and they just keep getting better and better. I think accessibility is not necessarily as much an issue as adoption. What I've picked up within, let's say within the tech environment, which is quite surprising. So data scientists, data engineers, even software developers, that some of whom I've spoken to, particularly those that are junior, have a resistance to using the technology because there's a view that, am I doing work if this thing is writing my code? Am I doing work if, this thing is giving me the insights or giving me the answers? Am I doing work if, so there's this resistance which I've met, surprisingly quite. So I'm someone that like these types of advances come out and I'm excited and I'm using them, but the adoptability I've found very slow. Like teams are not necessarily integrating this into their workflows and things like that. And it's almost like something that people use or remember, for specific use cases, but they're not using it at scale. So yeah, I think adoptability has been a big issue. And that becomes a major issue because effectively the expectation has changed in terms of what the production of a knowledge worker should be. So someone like me, for instance, if I've got a team of, let's say, analysts that there's certain work that has to be done. Last year, I may have expected that type of work to get done in a week, but because I now have access to the technology and I know that I can, do something in a couple of hours or less, it means that if you are not adopting the technology, it is felt by those that are. And unfortunately, that sort of causes a bit of friction, if that makes sense. So, and I think it hasn't come out to play yet because it's early stages. And living in South Africa, I guess, blinds us from some of those realities. But if you go to places like California or in the States, where this is almost the standard now within the tech community, it sort of shows you that, those guys are building these things. And if we're not adopting at that rate, especially if you're someone that's, coming into the field, there's, as I said earlier on, there's probably like, kids in first year now that already have access to these tools. And I can't wait to work with those guys, is what I tell some of the guys that are not adopting the tools. I can't, because we maybe just to sort of close off on like this is that I think people get married to tools and to technologies and find it very hard to sort of move away from those because they've attached their value to those tools and technologies and not necessarily the actual output, which is the solution. So yeah, I found that to be very, very challenging and frustrating.
Awesome, thank you.
Thanks, Julian. And then Melissa, I see your hand, you can unmute.
Hear me? Am I coming through? I'm not sure.
Yes, you are.
Okay, good. I just wanted to check, in your experience, how reliable has the synthetic data been that you've had within the spatial context? And if there is an error, has it been relatively easy for you to notice? Obviously, because you've got the spatial knowledge. So it's just coming to the point of how risky is it using these models, and then would it be very easy for a spatial specialist to miss like a gross error that's coming through in the results?
Thanks for that. I think that's a really good question. So I think there's a distinction between synthetic data for filling in for missing data versus generating synthetic data for, let's say, scenario modeling, or some task where you don't have the actual data set yet. And within the case of filling in for missing data, one of the more important things, speaking to accuracy, is around providing as much context as possible. So maybe speaking to Chad's question as well around adoption, I think a lot of people, as powerful as these models are, you kind of need to tell them what you want. So people are not investing in things like prompt engineering, which is effectively typing as much context as possible and allowing it to sort of give you a strategy. So people just sort of, you go into it and it's like, hey, here's some data, generate code that helps me with this and this. And it's like, okay, that's what this is all you're telling me. And a better way to think about it is, hey, here's a problem that I'm solving. I've got this type of data set. I'm optimizing for X, and I want to minimize any form of like a risk and errors which could arise from this exercise. Based on all that I've given you, based on my parameters, based on what I'm optimizing for, what are the strategic steps and best practices that I should follow for this? And so I'm going to give you sort of a view, and then you have a conversation, right? A back and forth, almost like you're talking to a specialist, because it's basically taken all the knowledge context in the world around how this particular task you're asking for is done and what are the best practices there. And then once you've got that view, you're now able to implement, right? So based on this, implement this particular sort of, and then now you've got questions around, well, I'm concerned around sort of the accuracy of the output here. Give a deep analysis and critique this approach and something like that. And then it's going to give you sort of a view of like, okay, this is this is that, and this is that. And then another point is around leveraging multiple sort of models. So GPT and BARD are freely available. You can literally have them fight against one another. So it's just like, okay, here's synthetic data that's generated using this. Provide an extreme critique. Here's some context, and you just have to type. You just have to provide it as much context as you possibly can. And then speaking to accuracy, so there's a difference in accuracy when you see these things as engines to process your data versus when you just ask it general questions like, hey, how do you do this? I think there's accuracy benchmarks online, and it's really, really sort of good these days, depending on the question you're asking them. So, GPT doesn't do too good in mathematical problems and things like that, but it might generate code for you that solves mathematical problems. But when you look at accuracy from a point of, here's some data, process this data, give insights on this data, I've found that I have no concern on accuracy with something like that, where there's no external data coming in, where you lock it in and say, only focus on this particular data set. And now you're talking directly to that data set. It's all like you're mining from that data set. If it's not including anything from outside, then yeah, it becomes a bit more. Yeah, I've never had concerns around accuracy for that. It's mainly asking more sort of public domain or public knowledge questions. Google Bard doesn't do too great with that. The new one might.
Wow, brilliant. Thank you. That was really, really insightful and helpful. Thanks.
Thank you. Thank you. That was a good question, Mel. Yes, and thanks for the response, Julian. I'll take one more question. If not, then we'll do our closing remarks and end the session. I see Mr. Parker has joined the meeting as well. Okay, there's a question in the chat. Let me just read it. Okay, so there's one more question from Kumalumbido. So the question is, how do you think these amazing Gen AIs will affect plagiarism and novelty in research? I'm sure things like Turnitin are freaking out.
Oh, that's thanks. So yeah, maybe I might not be the best person to speak to that, but what I've seen is it's a growing problem in academia. There's actual tools that you can use. So there's generative AI models that specifically are trained to beat the tools that the academic institutions are using to pick up whether you've used GPT or not. So you can literally beat those benchmarks now, where you generate a paper, you put it on these tools that the academics are using. It says you've got 90% plagiarism. You take that same data, chuck it in these new sort of LLMs, which are trained to beat them, and you can basically beat it. So in terms of how it's going to affect research, I can't speak to that. I don't know. I think really great researchers will be able to move faster. So in software development, there's this idea of a super dev now, in sort of like the idea of developers is basically being abstracted to say that, well, if you give a really good dev these superpowers, they'll become a super dev who'll do the work of like 5 or 10 people. I suspect it might be true for academia as well, but that's just a hypothesis. I don't know.
All right, thanks. So I see Mr. Parker has joined the meeting. Mr. Parker, would you like to just share a few words as well? I'm not sure how much of the session you're able to catch, but Mr. Parker, I'll just give you a few minutes as well.
Thank you very much. Not a few minutes. I actually just wanted to express my. I joined about 15 minutes ago while I'm in another, while we're on a break. But from listening to what you have said, I really want to firstly thank you very much for making yourself available and to sharing your thoughts. And it's really sincerely appreciated. And we hopefully want to embark on much more of this kind of exercises where we share knowledge like you are doing. But I actually wanted to ask you a question. The digital divide is getting so big. There are those that are in, for example, like yourself in programming, and there's a whole lot of us that are actually either scared or so unsure of how to even start with this journey of getting into, for example, coding and the kind of areas that you have embarked on. Do you have any word of advice for those on the other side of the fence who perhaps feel so intimidated to even venture into this, that they perhaps think it's beyond them, yet we perhaps all studied the same qualification? Do you have any advice for us to break that perhaps fear and overcome some of those mental barriers that we have to get into this kind of the digital area and the future technologies that you have exposed us to today? Thank you very much.
Thank you for that. I would say that just based on sort of the premise of this presentation, the idea is this is a massive opportunity for anyone at any level. So basically, language models have democratized so much in terms of knowledge work, and what that means is, if yesterday there was a barrier to entry to becoming a Python developer or becoming an analyst or becoming something, there's not as much of a barrier today, with some of the examples that we've basically spoken to, where you can now perform geospatial sort of computation or analysis using language or natural language, and things like these. So this is a really good example where you ask this sort of GPT view to say, give me a view of this particular problem. It tells you exactly how you do it. So in this case, it's not doing anything for you. It's telling you, you need to open GIS, you need to open your project, you need to do this, you need to do this, you need to do this, you need to do this. So I would say, as a summary, I think people need to invest in prompt engineering, which is the art of asking the right questions. And then once you've got a view of that, and it's an ever-evolving field, you'll basically be able to ask questions around your particular interests. So not necessarily just implementing things like, like the implementation component, but things like strategy. So we use it a lot for things like strategy as well. Like, if I want to become this, here's my context, here's my qualification, here are my strong points, here's this and here's that. Based on this, what is a pathway towards doing X, Y, Z? Is this strategic? Is it not? Those types of things, which I've leveraged for questions where people are transitioning away from other domains into data science and sort of doing the analysis based on their data, literally taking their LinkedIn data, their CVs, everything, their interests, recording conversations with them. So for instance, after this call, I'm actually going to transcribe this entire call. I'm going to take the transcription of the recording of this call. I'm going to put it in an LLM, and I'm going to use those summaries to tell my team what the strategic insights were from this talk. So yeah, hopefully that answers the question and gives some sort of calmness, because as I said before, I don't think this is a threat. I think this is a massive opportunity.
Yeah,
Thank you very much.
100%.
And very helpful response.
Yeah.
Fantastic. Thank you.
Thank you. There's a question from Sifiso. Sifiso, I think you'll be the last hand. So you can unmute and then you can ask your question as well. Sifiso, you can unmute. Okay, I think he's lowered his hand. Okay, oh, he was clapping. Okay, no problem. So, okay, he was clapping. So I think then that brings us to the end of our discussion today. Just some closing remarks from me, and on behalf of, I'll start off on behalf of management. So fortunately, Mr. Parker is here, but also the senior management of our branch as a whole. We wish to extend our gratitude again for taking the time to come and share your learnings and, you know, some of the insights that you have regarding this space. And we really look forward to further engaging with even other people as well working in a similar space to assist us internally in our data creation, our data analysis, and our data cleansing projects that our department, our branch, is currently embarking on. So for us, it was a very insightful exercise, and also for the students as well, who are currently busy with their own particular projects, you know, and how they can also leverage some of the capabilities of the AI tools, which are freely available for them to use. So yes, with that said, and to everyone, we will share the recording and also the transcription as well. I'll ask Julian to share his transcription and some of the insights which are coming out of this discussion today, so that we can also then analyze them further ourselves. So with that said, I think thank you everyone, and wish you all the best and enjoy the rest of your afternoon. So with that said, we'll end the session.
Thanks, everyone. And I've shared it on the chat, by the way. I've shared the insights.
Thanks, Bami. Thank you. Thank you. Thank you.
Cheers,
Bye.
everyone. Thank you.
Goodbye.
Bye.
Thank you.
Bye.
Thank you.